We are going to talk about connected body problems. You say, well, we've already done connected body problems, or connected object problems, I should say. Well, what we're going to do is we're going to introduce bendy connected object problems. So what do I mean by bendy? Well, we're going to look at three of these kind of problems. Okay, so why are they called bendy? Well, here's a connected objects problem. I've got this glider on an air track, so it can move without friction. There is a string connecting it to this object here, some weight, some mass, just call it object 2. So they're connected, but notice the bend. Okay, so this is the difference. That's why they're called bendy, or that's why I call them bendy. Okay, so what's happening is this lightweight thread, lightweight string, goes over a pulley. And so this is where the bend is, okay? And your job is to solve these kind of problems. All right, so here's the kind of problem here's the same problem, okay? So what would I be asking of you? Well, I want to know, given this situation, I want to know what the acceleration of number 2 is, or object 2 is, as it falls to the ground. And we know it's going to fall. You don't have to take physics to know that. If there's no friction under object 1, and there's the slightest tug of gravity on number 2, then gravity is going to pull down on object 2, which will cause object 2 to pull down on the string, which will cause the string to pull on object 1, and this whole thing is going to accelerate. Of course, 1 is going to accelerate sideways, and 2 is going to accelerate downward. So I want to know what acceleration number 2 is in this case. Another problem would be that I might want to know is what's the tension in the string between objects 1 and 2. So you can see there's some, it sounds like a connected object problem from the previous homework assignment, but the key difference is, what do we do with this bend? All right, so some key things to point out, and this was true of our previous connected object problems, is the acceleration of object 1 and the acceleration of object 2, well, they're going to be in different directions, but it's going to be the same magnitude. So the size of the acceleration is going to be the same. In order to say that, we have to, well, I'll just leave it here. Another point is our pulley must be a magical no friction pulley. Well, in reality, it just means that this pulley has to turn without much resistance. So we're going to say that it's a frictionless pulley. And of course, the string, as always before, has got to be lightweight, of mass of no consequence. Now, another thing that I really haven't emphasized before, but I want to now, is this idea of the tension. So whenever you have a tension problem, a string involved in a problem, then we want to just, well, here, I don't know if I want to remind you, because I don't know if I've ever emphasized this before, but the tension pulling in at both ends of the string will be the same. So the tension force pulling object 1 to the right is going to be the same in magnitude as the tension force pulling up on object 2. Because object 2 isn't going to be in free fall, right? It's going to move much more slowly than free fall, and that's because this tension force is pulling up on it. Okay, and I guess another thing is, since we're talking about it, we can say, okay, well, the force, well, I better, don't want to go into too much detail. This is just an introduction, Mr. McIntyre. Well, there's going to be a gravity force down, and that's going to be m2g. Okay, that's bendy problem number 1. Let's talk about bendy problem number 2. It's another connected object problem. All of these bendy problems involve a pulley. So this one, here's our pulley, and there's a lightweight string connecting two objects, and here's object 1 and object 2. So this is mass 1 is for object 1 and mass 2 is for object 2. All right, And what I want to know is, in this case, I want to know the acceleration of object number 1, and I want to know the tension in the string. So we basically want to make the same points as we did in the previous one. Okay, let's just assume for now that since it's a bigger block, we're going to assume that mass 1 is bigger than mass 2. So again, you don't have to take physics to know that if there's no resistance to turning in this pulley, it's frictionless, and this weighs more than this guy, then this guy is going to accelerate downward, and this guy is going to accelerate upward. Okay, so we can also say, like in the previous problem, so whatever acceleration 1 has down, 2 is going to have the same acceleration up. So there is only one magnitude acceleration. Two different directions, but one magnitude acceleration. Also, as we said in the previous problem, is that 1 isn't going to be in free fall, right? It's going to move down because the tension force in this string is going to be resisting that downward motion, basically. So it's going to accelerate because gravity force down is going to be greater than tension. But that tension force pulling up on 1 is going to be the same as the tension force pulling up on 2 because the tension at both ends of this rope are going to be the same. All right, number 3 gets weirder and weirder. Okay, in this problem, again, we have our connected objects. In a bendy connected object problem, there's always going to be a pulley. And we're going to assume this pulley always has no friction. So I'll just write it one more time. Or you can say negligible friction if you don't like magic pulleys. The string is always going to be lightweight. For now, we're going to say no friction as block 1 moves on the inclined plane. And what else do we need to? Oh, and then the tension, if we want to think about it, then whatever tension force is pulling up on 1, that we're going to have exactly the same amount of tension force. That the tension forces are going to be equivalent. And again, the questions I'm going to ask would be, what is the acceleration of block 1 as it goes down the ramp? What is the tension in the string? These are the 3 bendy connected object problems we're going to be analyzing in section 5.8. In the next videos, we'll go over the solution process for these 3 problems.